About 400 kilometers above Earth, a structure the size of a football field circles the planet faster than any bullet. It is not a distant future concept or a temporary spacecraft. It is the International Space Station, usually called the ISS, and for more than 2 decades it has been one of humanity's most remarkable engineering achievements. It is a laboratory, a home, a construction project, a diplomatic symbol, and a machine that must keep its crew alive in one of the most hostile environments imaginable. Every roughly 93 minutes, it completes another orbit, watching day turn to night and back again more than 15 times per day. The ISS is located in low Earth orbit, close enough to Earth that visiting spacecraft can reach it, but high enough to remain above most of the atmosphere. At this altitude, the station still experiences a tiny amount of atmospheric drag, which slowly pulls it downward over time. That means it occasionally needs reboosts from docked spacecraft to maintain its orbit. It travels at about 7.67 kilometers per second, or roughly 27,600 kilometers per hour. At that speed, the crew is constantly falling around Earth rather than falling into it. This is why astronauts experience microgravity, not because gravity is absent, but because the station and everything inside it are in continuous freefall together. The scale of the ISS is difficult to appreciate from photographs. With its solar arrays extended, it measures roughly 109 meters by 73 meters, making it comparable in footprint to a full-sized football or soccer field. Inside, its pressurized volume is about 1,005 cubic meters, similar in scale to a large airliner such as a Boeing 747. But unlike an aircraft, the station was not built in one piece. It is modular, assembled step by step in orbit from dozens of major elements. Each new piece had to launch through Earth's atmosphere, rendezvous with the station, and connect with extreme precision while traveling at orbital speed. The ISS exists because several space programs chose cooperation over duplication. It is operated by 5 partner space agencies: NASA from the United States, Roscosmos from Russia, the European Space Agency, Japan's JAXA, and the Canadian Space Agency. This partnership made the ISS the first space station built, maintained, and crewed through such broad international cooperation. Its roots go back to earlier plans, including the United States' proposed space station Freedom and the Soviet Union's Mir 2. Instead of building separate rival outposts, those ambitions were eventually combined into a single station. The result was both a technical project and a political statement: space exploration could become a shared human enterprise. Construction began in 1998, when the first ISS module was launched. Over the following years, major components were delivered by Proton rockets, Soyuz rockets, and the Space Shuttle. The station grew through a long sequence of launches, spacewalks, robotic operations, and careful integration. One of the most important structural features is the integrated truss structure, the long backbone that supports the station's enormous solar arrays and radiator systems. Those solar arrays generate the electricity needed for experiments, computers, communications, lighting, life support, and daily operations. The radiators are just as essential, because in space, heat cannot simply drift away into air. It must be actively managed and radiated into the vacuum. The station is divided into 2 main sections: the Russian orbital segment and the US orbital segment. The Russian segment, developed by Roscosmos, includes systems for propulsion, guidance, docking, and crew operations. The US orbital segment was built by NASA, ESA, JAXA, and CSA, and includes laboratories, living areas, storage, robotics, and other key infrastructure. Together, the station contains 16 major pressurized modules and 43 different modules and elements in total. These are not interchangeable rooms. Each has a specific purpose, from science and habitation to spacecraft control, airlock operations, and logistics. The entire station functions as an interconnected ecosystem of machines, people, and procedures. One of the central purposes of the ISS is scientific research in microgravity. On Earth, gravity constantly influences fluids, flames, cells, materials, and the human body. In orbit, scientists can observe how these systems behave when that dominant force is greatly reduced. Experiments on the station study biology, medicine, physics, materials science, combustion, Earth observation, and technology for future missions. For example, researchers can examine how muscles and bones weaken in space, how fluids move without settling, or how plants grow when their usual sense of up and down is disrupted. These studies are not only about space travel. They can also help improve knowledge and technologies used on Earth. The ISS is also a home, and that fact makes it different from most spacecraft. Since November 2, 2000, when the Expedition 1 crew arrived, it has hosted continuous human presence in space. That uninterrupted occupancy has lasted longer than any previous space habitation effort. Astronauts and cosmonauts live on a schedule that balances science, maintenance, exercise, communication, and rest. They must work out for hours each day to reduce the physical effects of microgravity. They sleep in small crew quarters, eat packaged food, recycle water, and follow strict procedures for everything from repairing equipment to responding to emergencies. Life aboard the station is extraordinary, but it is also routine by necessity. Keeping the station supplied is a constant logistical challenge. Crew members have traveled to the ISS aboard Soyuz spacecraft and, more recently, SpaceX Crew Dragon capsules. In the past, the Space Shuttle played a major role in bringing large station components and crew to orbit. Cargo vehicles are equally important. Progress, Cargo Dragon, Cygnus, the automated transfer vehicle, and Japanese cargo craft have all helped deliver food, water, equipment, experiments, spare parts, and fuel. The ISS includes multiple docking and berthing ports so different visiting vehicles can connect. Each arrival and departure must be choreographed carefully, because the station depends on this steady traffic to remain functional. The orbit of the ISS is carefully chosen. It travels between about 51.64 degrees north and south latitude, allowing it to pass over much of the inhabited Earth. This makes it useful for observing the planet, from weather patterns and storms to cities, coastlines, forests, deserts, and natural disasters. Its altitude keeps it below the Van Allen radiation belts, reducing radiation exposure compared with higher orbits, while also placing it above much of the denser atmosphere. However, space debris remains a serious concern. Even tiny fragments can cause major damage at orbital speed. The station is shielded in many areas, and controllers can move it when a threatening object is predicted to pass too close. The ISS has also become a measure of how many nations have entered the era of human spaceflight. As of August 2025, 290 individuals from 26 countries had visited the station. Some arrived for long-duration expeditions, others for shorter missions, but together they turned the ISS into a shared destination rather than a single-country outpost. At the same time, the station has had to survive political tension on Earth. Cooperation between partner agencies continued through changing governments, budget debates, and international disputes. This does not mean the partnership has always been simple. It means the technical dependence built into the station made cooperation practical, valuable, and often necessary. The future of the ISS is now one of the biggest questions in human spaceflight. The station is expected to remain operational until the end of 2030, with plans for commercial activity to expand before then. Axiom Space is expected to add the payload power thermal module, helping form a commercial segment that could eventually support Axiom Station. Russia has also planned future orbital infrastructure of its own. After 2030, the current plan is to deorbit the ISS using a dedicated U.S. deorbit vehicle, guiding it safely into Earth's atmosphere over a remote ocean area. But some critics argue that instead of destroying such a historic structure, parts of it should be moved to a more stable higher orbit. Whatever happens, the ISS has already proven something profound: humans can build, operate, and live aboard a permanent laboratory in space through cooperation across borders. If you found this helpful, Please like this video and subscribe for more explainers.